So this is the first project I'm going to be showcasing on here. It's basically a 0 through 9 counter where when you push a button, it's just going to cycle from numbers 0 through 9. So this basically just works by pressing a button, which just basically gives power to a clock, and then that clock is going to drive a 4-bit counter driver thing, which I'll explain in a minute. And then that's basically just going to send the binary information to a little bit of a decoder, which I'll also get into in a minute. And then that decoder just sends some signals to this 7-segment display, which you can see right here. So this circuit can be derived into 4 main components. The first is the clock, which is the NE555 timer, which basically just drives the 4-bit counter. And basically what the 4-bit counter does is it takes the clock input and then cycles through multiple binary outputs. As you can see, there's A, B, C, and D. That's the binary coded output. And then it's going to take that and then basically just send it to the decoder. And the decoder, which is the CD4511, that basically just takes the binary information and then translates it into 7 outputs that the 7-segment display can use to figure out exactly what number is showing up at that point. So the first chip that I'm going to get into is the NE555 timer. If you know anything about circuits, this is a super common chip that's used, especially in older circuits. But basically all this does is it takes a solid signal like a 5-volt input, and then it just basically converts it into multiple small pulses that go up and down really quickly. And then that cycle is what drives the 4-bit binary counter. So this next chip that I'm going to talk about is the 74LS90N. Now basically what this does is it just takes a clock input from the NE555 timer and it just converts it into several different binary outputs. And then if you decode those binary numbers, it just goes from 0 all the way through 9, which you can see in a little bit. So the last major component here is just called the CD4511. Now basically all this is, it's a 7-segment driver, so basically it just takes the 4 binary inputs. In this case it's A, B, C, D, and you can actually see that on the pinout of the CD4511. And basically what it does is it takes the inputs and then it decodes them and then basically just sends them to the 7-segment display so that it appears as a number, not some arbitrary binary output. So lastly, and probably most importantly, is the actual 7-segment display itself. Basically what this does is it's just 7 individual LEDs, and given each input from the CD4511, it just appears as a number through several LEDs. It's pretty self-explanatory. Alright, so this right here is basically just a representation of what's going on in the actual circuit that I just built. Not exactly, but about as close as I can get. As you can see right here, Q0, Q1, and Q2, those are the binary outputs that are basically just similar to the outputs of the 74LS90. So basically I can simulate this right here, and what it does is it just cycles through these numbers in a binary format. So for example, this is the the first place of a binary output, and then this is the second one right here, and then this is the third one right here. So when you put these all together, it goes 1, 2, 3, 4, 5, 6, 7, etc. So basically the way this works though in binary, if you're not familiar with it, is the combinations of different binary outputs like 1, 2, and 3, for example, that equals 7. 1 and a 0 and a 1, that's gonna equal 4. So just stuff like that. It's quite complicated, but once you get the hang of it, it's understandable.